And this video is about the problem 2, and the problem asks to collect the definitions of properties of the stochastic process with these 8 processes and explain the understanding about these properties. And first, let's see the white signs stationary process. The definition is a process is WSS if the mean is equal to eta is a constant, and the E of xt plus tau and xt is equal to r tau, and xt is SSS, and E of x squared exists, which means xt is a WSS, and xt is a WSS cannot have xt is XSS. Xt and yt are jointly WSS if each one is WSS, and E of xt plus tau yt is equals to rxy tau. Xt is normal, and the WSS can have xt is SSS. And the next one is independent increment process. The definition is that the means x1 minus x2 and xt3 minus xt4 on non-overlapping intervals are independent. Independent increment can imply a correlated increment. Poisson process, random walk, and the Wiener process are independent increment. The next one is Markov process. A process xt is Markov process if the past has no influence on the statistics of the future under the condition that the present is known. For any n and t1 greater than t2 greater than tn, we have this. And Poisson process, Poisson impulse, semi-random telegraph signal, random telegraph signal, and random walk and Wiener process are all called Markov process. And the next one is normal process. This is also the Gaussian process. Xt is said to be normal if the random variable xt1, xt2, xtn are jointly normal for any n. And that is the f x1, x2, t1, t2 is equals to this formulation, where eta is ex c equals to e of x minus eta, x minus eta. The statistics of a normal process is completely determined in terms of its mean and correlation, or the autooccurrence. Wiener process are one example statistics process, but the normal process as a property of the statistics process, so that we know that the normal process is a statistics process, but the Wiener process is only the one example of this. The next one is a strict sense stationary process. Xt is stationary in strict sense if its statistics is not affected by a shift on the time. We know that xt is XSS if f x1, x2, t1, t2 is equals to f x1, x2, t1 plus delta, t2 plus delta for any n, t1, t2, and delta. Xt is SSS, so it implies that fx xt is equals to fx. And xt is an SSS, can have the mean is the constant, and RT1 T2 equals to RT1 minus T2, which is the R tau. And the next one is white noise. VT is a zero mean white noise if RT1 T2 equals to QT1 and delta T1 minus T2. If ZT is the Poisson impulse process, this we have discussed before. So the ZT minus lambda is a white noise, and the WT dt is a Gaussian white noise, where WT is a Wiener process. And the next one is mean ergodic process. XC is said to be mean ergodic if the limit t to infinity 1/2t, the integral of xc dt is equals to the mean. And the xc is said to be if the mean square sense means that the limitation of this is equal to 0. So if it is the mean ergodic process, we can have this function, this formulation. And the next one is the Martin-Gall. The condition mean equals the condition is the true for random walk and Wiener process. And so this is the problem 2.